Out in the deep universe, gravity can become so intense that a passing star is ripped entirely apart. Astronomers call this a tidal disruption event. When a supermassive black hole consumes a star, the resulting flare releases as much energy as hundreds of billions of suns. It's an explosion that briefly outshines the entire host galaxy. Astrophysicists actively hunt for these fleeting bursts of light. Catching one in the act is one of the only ways to observe the extreme physics operating immediately outside a black hole's event horizon. To understand how the universe actually works, we have to look closely at how it tears its own fundamental building blocks to pieces. Under normal conditions, a star is a delicate balancing act. It maintains its shape because its internal self-gravity pulls all that superheated plasma tightly towards its core. But every supermassive black hole has an invisible boundary surrounding it, known as the tidal radius. If a star drifts across this line, the black hole's immense gravity overtakes the star's own internal pull. Think of it like water approaching a drain. The gravitational pull on the leading edge of the star is exponentially stronger than the pull on its trailing edge, stretching the star out of its spherical shape into a long vertical column. At the exact same time, the converging gravitational field lines of the black hole squeeze the star horizontally inward. Astrophysicists refer to this precise mechanical process of simultaneous vertical stretching and horizontal compression as spaghettification. Crossing the tidal radius shatters the star's structural integrity. It ceases to be a solid spherical body and becomes a continuous, highly vulnerable stream of superheated plasma looping around the abyss. In September 2019, an optical telescope in California detected a massive, anomalous surge of light coming from the constellation Eridanus. Astronomers officially cataloged the event as AT 2019 QIZ. It was the complete shredding of a sun-like star by a supermassive black hole weighing 1 million times the mass of our sun. Because it occurred relatively close to Earth, telescopes globally captured an immense volume of multi-wavelength data. It became the gold standard observation for this kind of cosmic event. That high-fidelity physical evidence gave us exactly what we needed to map the step-by-step chronology of a star's death spiral. Popular culture often pictures black holes as clean cosmic vacuum cleaners that quietly swallow matter whole. The reality is incredibly violent and messy. When the star is spaghettified, the black hole doesn't capture all of it. Roughly 50% of the star's mass is violently ejected outward into deep space at speeds reaching 10,000 kilometers per second. The remaining 50% stays gravitationally bound. This plasma swings around the black hole in highly eccentric, elongated elliptical orbits. As the plasma tail loops back, it violently crashes into the incoming stream of new debris. Astrophysicists call this a stream-stream collision. Friction and kinetic shock waves heat the gas to millions of degrees. Over time, this disorganized gas circularizes, forming a flattened, glowing accretion disk. The black hole itself emits no light. The galaxy outshining flare we detect from Earth is generated entirely by the immense thermal energy of these messy stream collisions. Observing the deep cosmos comes with a built-in limitation: the finite speed of light. Everything we see is tied to how long it took the photons to cross the void. The galaxy hosting AT 2019 QIZ sits 215 million light-years away from Earth. This means the massive flare captured by California astronomers in 2019 actually occurred 215 million years ago. The light simply took that long to reach our lenses. While that sun-like star was actively being stretched and spaghettified into oblivion, the very first dinosaurs were just beginning to roam the Earth during the Triassic period. Modern telescopes operate as literal time machines. We are witnessing the ancient, violent destruction of a star eons after its debris has settled. Supermassive black holes have a reputation as purely destructive monsters, but they also function as crucial cosmic engines. Remember that 50% of the star's mass that was blasted away at 10,000 kilometers per second? That high-speed exhaust mechanism seeds the wider galaxy with heavy elements. Over millions of years, those recycled stellar remnants cool and coalesce. They provide the raw material to form new star systems, rocky planets, and potentially the necessary chemical building blocks for life. If you want to keep exploring the extreme physics of the universe with us, hit the subscribe button down below. And let me know in the comments, in this scenario, would you rather be the star or the black hole? The terrifying death of one star at the hands of a black hole is an absolute requirement for the birth of